I'm Martin.
Hi, I'm Justin Porting.
Hi, I'm Elliot Nunn.
And we are Simba. Safety engineers make
make
bad
bad
actors.
Today we'll be talking about 5 different kinds of process safety incidents and what you can learn from them to ensure that you have a safer process. First, we'll be discussing process safety management and how it pertains to workplace safety.
Next, we're gonna talk about compostable dust.
Third, we're going to talk about bloodies.
Fourthly, we'll be talking about sabotage in the process industry.
And lastly, we'll be talking about how toxic gas dispersion releases and how models and good safety culture can help minimize this risk and the resulting damage. During a routine operation at Matador's chemicals facility, a process control on the critical operations was accidentally changed. It was fortunate that the operation was not running when this accident occurred. Had this accident not been by operation before startup, a serious accident could have occurred. This correction highlights the importance of process safety, particularly in terms of operating procedures and employee participation. Hey guys, did you hear about the octopus that escaped from that New Zealand zoo?
Yeah, isn't that crazy?
How did he even do that? How do you know?
I heard he just burst through this enclosure and then somehow walked across the floor, went into this drain pipe, and then he just jumped out to sea apparently.
The octopus just walked out.
It's
What's
crazy.
the octopus?
I mean, was there no one watching him or something?
Yeah, I mean, how did he even get out? How'd the enclosure break? Do you know?
I don't know. I mean, the article didn't say. I mean, I guess octopus are just kind of genius in some way.
I
That's
guess so.
weird. I mean, you got 8 legs and use them, right?
Yeah. And Inky the octopus. So,
Inky. That was his name, huh?
crazy stuff, huh? I've never been to New Zealand, but maybe their octopus are just crazy over there.
I've never been there either.
Oh no.
Me neither.
Yeah, looks okay. Looks like Elliot hit this switch. That's terrible. It caused an explosion. I gotta go tell my boss. Boss, what if the control valves got hit?
Which valve?
That one.
Okay.
Yeah, it was really dangerous and explosions could have happened.
Oh man, was it on reactor 4?
Yeah, it was actually.
Oh man. Do you have any idea how it happened?
Yeah, I think actually the octopus from the New Zealand Zoo came over here and hit it.
An octopus, you mean Elliot?
Yeah, that guy.
Okay, man, that guy, he's, we need to work in our safety culture or something because he's always, bumping stuff and all that stuff. He needs to be careful.
He's not that bad.
Okay, we'll write some stuff up and, we'll talk about it next meeting. We'll see what we can do.
We'll have a safety meeting. That'll do it, right?
That sounds good.
Yeah. So that's why they pay you the big bucks, huh?
Yeah, that's me. Yeah. The previous scene showcased the importance of operating procedures and integration of employee participation in the safety culture at a chemical facility. Without the operating procedure in place to check the process before startup, a serious accident could have occurred. However, the negligence and complacency of the first group of employees, and Elliot, highlights the need to have a good safety culture in place at a chemical facility among all employees. It would be better for the process to be safe in the first place, rather than having to correct the error of an employee later on. Under OSHA, chemical manufacturers are required to develop and document procedures similar to the one mentioned earlier that prevent the accident from occurring. This pre-safety interview may have saved the lives of many people and the property at the chemical facility.
Here at Simba, safety is our utmost concern. Chemical plants have many hazards that face them. If you were thinking sabotage is one of them, you'd be correct. Sabotage can occur in many forms. Theft of chemicals or materials, contamination of products, and interfering with the process are just a few ways plants can be affected by sabotage. Not long ago, at Texas Tech University, sabotage came, and it was devastating. In 2015, a group of mass terrorists stole chemicals from one of the labs at Texas Tech University and sold it to a third party to fund their terrorist activities. The chemical that was stolen was chlorohexyl isopropyl sulfide, better known as CHIPS to the industrial world. Now, watch this reenactment.
Ah, yes, the chips.
I can't see anything out of this bag. Justin, these were a terrible idea.
Follow my voice. Get over here. Grab the chips.
I see the chips.
It's perfect for our terrorist activities.
These chemicals will net so much money for this.
Donate the product.
Ah,
Let's get out of here.
careful. Ow.
Oh no, the chip is gone. It's really dangerous. They can make a bomb from it. What am I gonna do?
I can't believe it's so easy to get the chips.
I know. We should have gotten more.
It's really funny. We'll be happy. Boss,
Yes.
we have the chips as you
Good deal. You will help me win the third term. You know what we're gonna do with these guys?
What?
We're gonna hold the city of Washington D.C. ransom.
Are they really that powerful?
Yes. This is like 2 nuclear bombs right here.
Oh wow.
I know.
I probably shouldn't have ate one then.
You ate one of these?
Yeah,
You idiot.
I know.
You're dead.
I know.
Luckily I've got more terrorists.
Okay, I'll just go get them prepared, and then you'll let us know on the rest of the plans.
Will do.
Sounds good? Okay.
Good job, man.
Careful. It's very dangerous.
Oh no!
Oh no!
Oh,
I'm clear!
You idiot!
No!
Oh no, are they ruined?
I don't know. Maybe you should try one.
I'll try one later.
You gotta be safer with these.
This mask, this bag is just, I can't see anything with it.
Ah, yes. That looks good. That looks good.
No!
You guys cannot have these chips.
I still can't see you stab me.
After this tragic incident, we here at Simba went to Texas Tech to see if this could have been prevented and what steps they should take to prevent another incident like this from occurring. After our analysis of the labs, we noticed that not all of the doors were locked and some chemicals were left out overnight. Our recommendations to them were to have someone, preferably an experienced engineer, to make sure all of the doors are locked while not present in the lab, to keep all chemicals locked in the correct cabinets when no one is using them, to install more security cameras, and to install a button to lock the doors to the lab from inside so no unwanted guests can have the chance of entering. After giving these recommendations to Texas Tech, we hope they follow through with them, but we here at Simba know that not everyone takes these recommendations very seriously, and in doing so, incidents like the chips theft at Texas Tech could happen again. We hope everyone understands the dangers of sabotage and what we can do to prevent it. For all of us in the safety field, we're Simba. You stay safe, Lubbock.
Combustible dust are fine particles that present an explosion hazard when suspended in air in certain conditions. A dust explosion can be catastrophic and cause employee death, injuries, and destruction of entire buildings. In many combustible dust incidents, employers and employees were unaware that a hazard even existed. It is important to determine if your company has this hazard, and if you do, you must take action now to prevent tragic consequences. There are 5 elements must be present for a dust explosion to occur. If any one of these elements is missing, an explosion will not occur. The 5 elements are needed for a fire. 1. Combustible dust, which is the fuel. 2. Ignition source, which can be heat or electric source. A 3rd one is oxygen in air. A 4th one is dispersion of dust particles in sufficient quantity and concentration. And 5th, confinement of the dust cloud.
Hey Ma, you ready to go to that party later?
What party?
Oh, the big one down the street.
When is it?
Oh, it's like right now. We have to go soon.
Right now?
Yeah, basically.
But I have lab work I need to do on.
Oh, I know you do, but this party's gonna be sick. We have to get going,
Okay,
so we're
just
gonna
give
miss
me
it.
1 second. I'll be right. Oh crap! I have to clean that.
No, the party. No, we have to go now if we.
But that's powder. It's
Oh no, it'll be all right. We'll clean up later.
Are you sure?
Yeah, don't worry.
Okay.
It's no problem.
Well, at least we
Just-
have to turn off the light.
Okay.
Make sure.
Okay, I'll get it for you.
Okay.
Cool.
Yeah. Yeah, I'll clean it up next time.
Huh. It's kind of dusty in here. Oh well. It's been a long day. Oh wait, I can't smoke in here.
To prevent a dust explosion, SEMPA recommends employers to implement a hazardous dust inspection, testing, housekeeping, and control programs. Use proper dust collection systems. Regularly inspect for dust residues in open and hidden areas. If ignition sources are present, use cleaning methods that do not generate dust clouds. Control smoking, open flames and sparks, including mechanical sparks and friction.
Good afternoon. The engineers here at SEMPA have a few recommendations concerning BLEVEs for the chemical process industry. BLEVEs are one of the most dangerous hazards in the entire industry. BLEVE stands for Boiling Liquid Expanding Vapor Explosion. These occur when a tank containing liquid above its atmospheric boiling point ruptures, resulting in an exploding vaporization of a large fraction of the tank's contents. This could result in a toxic release or vapor cloud explosion. When these vessels explode, large pieces of metal are launched at great speeds with the potential to hurt any bystanders or cause property damage. On the day of Wednesday, April 13th, a small group of undergraduate chemical engineers at Texas Tech University would soon have their first encounter with the BLEVE. This is their story.
Something looks concerning here.
Yeah, looks at that. It looks like the air is building up. Do you know what's wrong with it?
I think the cooling system's failing. That's not good. We need to go tell the boss.
Hey, one of the valves is open.
The relief valve. Oh no! We gotta go tell the boss. Boss, we got a situation.
Hey, one of the valves is open and it's leaking, I think.
The pressure's building in the reactor.
Oh no, that's not good. I don't know what to do. I think it's a BLEVE.
Do you? We gotta get out of here. We gotta tell everybody.
Okay.
Evacuate. Let's go.
Oh no, let's go.
The most common type of BLEVE is caused by a fire. First, a fire develops adjacent to the tank. Next, the liquid temperature and pressure in the tank rise, followed by the structural integrity of the tank being compromised when the liquid is vaporized, and there is nothing left to absorb the heat. Finally, the tank ruptures and explosively vaporizes its contents. Some other causes include physical damage from collision or impacts, overfilling, which can be prevented through pressure relief valves, runaway reactions, overheating from inoperable pressure relief valves, explosion in vapor space of container, and mechanical failure due to high rate of depressurization. However, there are some preventable actions. Most BLEVE incidences can be prevented with a properly designed pressure relief valve. The most common type of these valves are spring actuated or a rupture disc. However, this may not be enough if the liquid is boiling faster than the pressure can be released. New technologies have made great strides in the prevention of BLEVE accidents, but education and preparation will always be the most effective tools. Be sure that the workers, emergency responders, and local communities are made aware of potential chemical hazards and ways to contain or treat them. Check and double check safety systems such as relief valves and cooling systems. Be prepared with a plan of action in the worst case emergencies. If all systems fail, have an effective evacuation plan. As always, practice inherently safe design, minimize the amount of hazardous materials present at one time, substitute dangerous chemicals with less hazardous alternatives, reduce temperatures and pressures where possible, and simplify the process to allow for error tolerance. Thank you.
The safety consultant engineers at SIMBA have one final disaster example, and that is toxic gas release and dispersion. During any accident, process equipment can release a number of toxic materials quickly. These materials can spread throughout a plant and community silently, often leaving its victims oblivious. Large and small accidents throughout the chemical process industry demonstrate the need for emergency planning in the event of a toxic gas release scenario. On the day of April 23rd, a laughing gas release incident occurred to 3 unsuspecting Texas Tech engineers. This laughing gas was silent and left the engineers passed out, but they will laugh another day.
Oh man, gonna be on lunch break.
It's been a long day.
Oh yeah.
Man,
I have these chips.
gosh, all those projects.
Yeah, man, design is killing me right now.
Safety video.
Yeah, that's crazy, huh? 20 minutes?
10-minute video, man.
That's pretty fun though.
Got better.
Definitely helps reinforce concepts.
Yeah.
I'm learning a lot in our class, that's for sure.
That test was tough though.
Yeah,
I never knew how dangerous forklifts could be.
that's true. Guess people gotta really train their workers well.
Yeah.
Something smells kind of funny in here, huh?
The chips, man?
You think it's the chips?
What, do you remember one of those safety videos we saw or something that reminded you of that?
Yeah, I know, those gas leak videos are kind of crazy.
What?
Oh man.
Guys, what's going on here?
I don't know.
Putting up with the chip in your foot.
Hey Justin, did you ever get that gas dispersion modeling homework done?
Just barely. I mean, that was not a laughing matter, let me tell you.
I can't breathe. I'm laughing too much. It's too funny.
That feels so good.
Oh no. The previous scene depicted a toxic gas release where 3 engineers are victims of the accident while they are exposed to a dangerous concentration of laughing gas above the permissible exposure limit. Accounting for a number of factors could prevent their exposure or at least minimize the severity. First, the site did not have adequate dispersion models for all the possible gas releases located on site. This dispersion gas modeling should have taken into account whether the release could be characterized as a plume or puff, atmospheric conditions such as wind velocity, time of day, and cloud cover, gas release rate, and distance to a safe concentration below the PEL. Furthermore, the density of the gases and the height of the container the gas was released from should have been accounted for, as these would affect the characterization of the release. There are other factors that could affect the severity of the release, especially in light of the engineer's exposure. Adequate ventilation should be in place to prevent dangerous concentrations of gas from accumulating in space. Given that the brake table is located next to the laughing gas source, this is clearly not possible. Also, storages of large quantities of dangerous chemicals indoors can be extra dangerous, as the concentration can rise more rapidly in a small room volume than if the release with the Releasers Outdoors. I'm Matt Kowalski, and you stay safe, Texas Tech.
We hope the Simba safety investigations help to increase the awareness of these process-related hazards, including worker safety, sabotage, dust explosion, levee, and gas release, so that these incidents like the ones at the Texas Tech campus will not be repeated. Thank you for watching this Simba safety video, and stay safe.
We are Simba.
Safety engineers make bad actors.
Hi, I'm Matt Kowalski.
Hi, I'm Maiden.
Hi, I'm Justin Porter,
Hi, I'm Elliot Dunn.
and we are Simba, which stands for
Safety engineers.
Make bad actors.
Sorry, I forgot the name.
Whenever you're ready.
Oh no, the chip has gone. The chip has gone.
How's it look to you?
It looks okay.
It looks okay. Alright,
Oh, sorry.